The air is cool with the last of the night, and beneath your feet, the salt crust gives a faint, brittle whisper. Ahead, the Etosha pan opens into a white basin so broad that earth and light almost seem to meet without a seam. At dawn, the surface is pale clay, pale salt, and pale mirage, all resting under a sky that has only just begun to brighten. Nothing here appears to move at first, and yet the ground is full of quiet detail. There are fine tracks pressed into the crust, shallow hollows where water once stood, and a thin glitter where minerals have dried in the dark. This wide floor was once part of an older inland lake, shaped by vanished rivers, then left to heat, wind, and slow evaporation. What seems empty begins to read differently, as a record of water arriving, lingering briefly, and then slipping away again. With each careful step farther onto the white surface, firmness turns to powder, and the stillness becomes easier to understand. So for a while, we can stay here at first light and let this silent Namibian basin reveal how a landscape remembers water. The pan looks level from a distance, but a few steps farther in, that illusion starts to soften. Small ridges rise from the crust like frozen ripples, and between them lie shallow basins where the surface has settled, dried, and tightened again. That change matters because it means this floor is not one single sheet of salt, but a patchwork of places where water paused for different lengths of time. As the light strengthens, the first concrete clue arrives in the form of a narrow line of darker clay curving away to the east. It is not a crack and not a track. It is the faint outline of an older shoreline within the basin itself, a place where a thin sheet of water once slowed, spread, and then disappeared. Because that line is there, the whole pan begins to feel less empty and more like a page with writing only just becoming visible. You could continue straight out across the brightest white where the surface seems hardest. Or you could follow the darker curve and read the basin through what it has recently held. The choice is a quiet one, but it changes what the morning reveals. So you turn toward the darker clay, where the salt is thinner, and where the ground keeps a little more of its history near the top. At once the texture underfoot changes. The brittle whisper becomes a softer press, then a delicate crumble, as if the crust were only a skin laid over powder. That softness is the consequence of repeated wetting and drying. When shallow floodwater reaches this part of the pan, it spreads over fine sediment carried in from surrounding ground. Then the sun and air begin their slow work. Minerals stay behind. Clays settle, and the surface hardens only until the next brief return of moisture loosens it again. A few paces farther on, another development appears. Embedded in the pale clay are tiny white crystals, not spread evenly, but gathered in little seams and stars. They catch the low sun with a faint silver brightness. This is what evaporation looks like when it works slowly. Water lying here for a short time dissolves salts already in the sediment and carries them upward as the surface dries. When the moisture finally departs, the dissolved minerals are left behind in new shapes, delicate at the edges, bright against the quieter clay. Because the crust is so thin in this zone, each step has to become more careful. The basin is still, but it is not featureless. A careless stride would smear the fine records laid down over days and weeks. So the movement slows, and with that slower pace, more signs begin to gather. There are bird prints now, sharply pressed, and then softened by a breath of wind. There are hoof marks, shallow and rounded, where larger animals crossed when the ground was damp enough to keep an impression. And besides one depression lies a fragile crescent of lifted crust, where the mud below once swelled and then shrank. Each mark has a cause, and each cause belongs to the same simple sequence. Water comes in thinly, the surface softens, a bird walks through, the sun rises, the mud contracts, the salt hardens around the edges. Then the wind arrives, and begins to edit everything that remains. By now the dawn has moved from grey into a pale gold that never feels warm in colour, only clearer. The white basin reflects it upward, so the light seems to come from the ground as much as from the sky. That brightness reveals something farther out. Bands, almost too subtle to notice at first, laid across the pan in broad horizontal tones. Some are chalk white, some lean toward cream, some hold a cool grey beneath the salt. Those differences are another kind of record. Where the surface is brightest, evaporation has left a cleaner crust of minerals near the top. Where it dims toward grey, the clay fraction is stronger, or the salts have been broken and mixed back down by later moisture. The pan keeps sorting itself this way, with no haste at all. Rainfall in the wider catchment determines how much water arrives. Minute shifts in elevation decide where it lingers. Heat and dry air decide how quickly it leaves. Then the next season begins to write over what the last one left behind. A faint breeze moves across the open floor. It does not raise dust yet. Instead, it skims the surface and shows you another layer of the place. Tiny, loose grains rolling until they collect in the lee of each shallow ridge. Wind matters here because water is usually brief. After floodwater retreats or vanishes into evaporation, the open pan is exposed for long stretches. Then even the smallest particles are free to migrate. That is why the surface never remains perfectly smooth for long. The basin is level only in the broadest sense. Up close, it is always being rearranged. Near your feet, a cluster of tracks crosses the darker clay and disappears into a whiter patch beyond. The edges are neat enough to be recent, perhaps left in the cool hours before dawn. They belong to a bird, likely one of the waders that use the margins when moisture gathers there. The tracks do not continue because the crust changes. On firmer salt, impressions fail to hold. That absence is useful evidence too. It tells you where the pan was soft longest and where drying returned first, so even a missing print becomes part of the reading. The silence here is not total. It carries very small sounds. The dry click of your step, the whisper of moving air, a distant bird call from beyond the pan's edge where grasses and shallower wetlands begin. That distant sound matters because it points toward the larger system surrounding this white center. Etosha is not only the pan itself, it is also the rim of low grassland, the drainage lines that feed temporary water into the basin, and the subtle rise and fall of ground that decides where wet and dry will meet. This broad floor was formed through far older changes than a single season can show. Long ago, wetter conditions and different drainage patterns allowed much more water to collect here. Rivers that no longer reach this basin in the same way once contributed to a larger inland lake system. Over long spans, those inputs weakened, climate shifted, channels altered. Evaporation kept winning where inflow became uncertain, and so a lake became first shallower, then intermittent, then mostly memory held in sediment and salt. You can see that memory in the plainest materials. Fine clay settles in still water because it is light enough to remain suspended until movement slows. Dissolved minerals stay invisible while the water is present. Then dry heat removes the liquid and leaves the chemistry behind on the ground. Repeat that cycle enough times, across centuries and millennia, and a pan like this emerges, not built in a moment, but assembled through patience. The sun rises another degree, and the surface begins to glare. With stronger light, the shallow depressions become easier to detect. Some are only a few inches lower than the crust around them, yet that is enough. Enough to hold water briefly, enough to collect silt, enough to produce different drying patterns, and therefore different textures beneath your feet. What appears flat from the margin is actually full of such decisions. A slight hollow invites water to stay. Staying water dissolves and carries minerals. Lingering moisture softens the sediment. Then, when drying comes, that patch hardens in its own way. From these tiny differences, the wider mosaic grows. Farther ahead, the darker clay ribbon broadens into a low zone where the crust has fractured into plates. Their edges curl upward like thin pages. That shape reveals another consequence of drying. When wet mud loses water, it contracts. If the surface has already stiffened, The shrinking layer breaks itself into polygons and flakes. Later, thin salt may grow over those fractures, binding some pieces together while leaving others lifted. The result is a floor that looks almost tiled, though no hand ever arranged it. You pause here because this part of the basin is especially legible. The fractures run outward in irregular webs. Within some of them, white crystals have accumulated more thickly, as if the ground had traced its own fine map in mineral dust. The reason is simple enough. As the mud dried and split, capillary water rose towards those openings. The last moisture evaporated there, and the last dissolved salts were dropped at the edges. Even the cracks have chemistry. Now, because the sun is warming the basin, another change begins. The cool firmness of dawn gives way to a slight looseness at the very top of the surface, where delicate crust can dry past brittleness into powder. That change affects what can be read. Tracks begin to soften. Sharp impressions lose their edges. The pan is preserving and erasing at once. It always is. To the north, beyond the brightest span, there is the barest hint of shimmer. At first, it looks like water. Then it resolves into heat and reflection. Mirage, rising where the surface and warming air bend light together. Even this has a quiet part in the story. When the basin is dry, light behaves in ways that echo water without requiring any to be present. So the landscape keeps offering the appearance of a lake, long after the lake itself has gone. That visual uncertainty feels almost fitting here. The pan is made from repetition, and so are its illusions. Again and again, water returns briefly. Again and again it leaves. Again and again, the eye sees moisture in brightness, and memory in the ground. By now the edge where you entered is farther behind than it first seemed. Distance behaves strangely on salt flats. Without trees, rocks, or steep relief, scale thins out. A small ridge can appear close, then remain distant for many minutes of slow walking. A bird on the margin can seem suspended in the air. The horizon itself feels less like a line than a whitening. That makes the basin feel larger, but also calmer. There is little here to interrupt the long reading of surface and sky. Still, the real complexity lies low. Near one dried hollow, a faint greenish stain appears where the clay is exposed. It is subtle, almost erased, yet it suggests that when water last stood here, microscopic life flourished in the thin shallows. Algae and other tiny organisms can bloom quickly in temporary wet conditions, especially where light is strong and nutrients gather in pooled water. When the shallows vanish, traces may remain as muted color or as slight organic films mixed back into the mud. That small stain changes the emotional scale of the pan. The white floor is no longer only mineral. It has also briefly carried living color, nearly invisible now, but part of the same cycle. Water arrives, light enters the shallows. Microscopic life responds. Birds may follow. Then evaporation concentrates the salts, until most of that activity retreats or disappears. Nothing dramatic is required. A few days of water can alter the whole mood of a depression this size. You continue along the inner shoreline mark, and the evidence keeps layering. A narrow strand of shell fragments appears in one spot, so small you could miss it with one faster glance. These are not from a permanent shore. They are remnants from temporary aquatic life, gathered where retreating water or a light wind sorted them against a subtle rise. Because they are here, the curve in the ground gains credibility. The basin is confirming itself. This really was an edge, briefly. This really did hold a film of water long enough for life to occupy it. And because that happened here rather than a few yards away, elevation in this pan must differ by only the slightest amount. That is one of the most important truths in landscapes like this. In a mountain valley, great relief governs water, obviously. Here, a difference of an inch can redirect an entire shallow spread. The stakes are small in height, but large in consequence. A lower patch stays wet longer. Longer wetness changes salinity. Changed salinity affects algae, invertebrates, and the birds that feed on them. Then, when drying begins, Those same differences govern where new crust forms first and where mud remains open, so the quiet shape of the pan controls its changing life. The sun has now risen enough that the chill is leaving the air. Not quickly, just steadily. That slow warming brings a clearer view of the basin's margins. Far away, a darker rim separates the white pan from tawny grassland. That boundary may look sharp from here, but on the ground it is gradual. There are belts of transition, hard crust to damp margin to cracked mud, mud to sparse grass. And each of those belts responds differently when seasonal rain reaches the basin. The thought of that coming change gives the morning a gentle kind of tension. What lies dry now is not fixed in that state. Clouds gathering far beyond the horizon, rain falling in distant catchments, or runoff slipping through shallow channels can begin to alter this white floor long before any water is visible here. Cause begins elsewhere, effect arrives later. The pan is always waiting on distant weather. You stop beside a broad depression where the crust has broken open to reveal compacted grey sediment below. If the white surface is the current page, this darker layer is an older paragraph beneath it. Sediment here has not accumulated all at once. Each thin flood brings suspended clay and silt. Each drying period leaves mineral traces above or within that mud. Over long spans, these layers build a low archive. Not neat, not evenly striped, but still readable through texture, color, and chemistry. Some layers speak of fresher inflow, some of harsher evaporation, some of quieter water where only the finest particles could settle. This is where the basin widens in meaning. It is not just a white plain under sunrise. It is a record of changing water balance across northern Namibia, written in minerals that stayed when water could not. And as the light grows more exact, the floor begins to show one more thing. Not only what has happened here, but where the next changes will begin. Ahead, the white crust softens toward a more mottled margin, where pale mud and sparse vegetation seem to test each other's reach. That edge is where moisture lingers longest after rain. It is where salinity eases just enough, in places, for grasses and low plants to gain a temporary hold. And because life gathers where the conditions loosen even slightly, that distant rim is where the still basin will soon begin to feel less solitary. So you begin to drift toward that rim, where the pan loosens its hard white silence and becomes a more complicated ground. The change is slow enough that at first you notice it only in color. The bright mineral skin gives way to patches of beige and gray, then to faint olive tints where low plants have managed a brief, careful hold. Nothing rises much above the surface. Even the grasses seem to keep their heads low here, as if they understand that water is never fully promised. That uncertainty shapes everything at the edge. A shallow hollow may hold rain for a few days longer than the ground beside it. A barely higher patch may dry first, turning firm while the next step still yields to mud. Because of that, the margin is not a line at all. It is a band of small decisions made by water. You can read those decisions in the cracking earth. The fractures here are wider than the ones farther out on the pan. Some have opened into narrow polygons with raised rims, each plate drying at its own speed. Others have been softened at the edges, as if a last film of moisture lingered there after the center had already gone dull and hard. That tells you something simple and important. Fresh water, when it reaches these margins, does not arrive in a perfect sheet. It collects unevenly. It seeps. It pauses where the sediment is fine and moves on where the ground is slightly higher or more compacted. Then salinity begins to sort the landscape from below. The closer a patch remains to trapped salts, the fewer plants can hold there. The more often it is rinsed, even briefly, by less saline water, the more likely grasses or low shrubs are to appear. So what looks scattered is not random, it is chemistry made visible. A clump of wiry grass stands ahead, pale gold in the growing sun. Around its base, the ground is darker, not because shade has lingered there, but because roots have changed the soil. Where plants grow, even sparsely, they slow the wind a little. They catch drifting particles. They hold moisture a little longer after rain. The sediment beneath them becomes subtly different from the bare flats only a few steps away. Life, even in quiet amounts, begins to engineer the edge. You pause near one of these clumps and look back. From here, the white basin seems even wider than before. Its surface is bright enough to blur into the horizon, while the margin underfoot feels textured, inhabited, almost conversational by comparison. That contrast matters. The pan's center and its edge belong to the same system, but they speak in different ways. The center records broad cycles of inundation and evaporation. The margin records hesitation. It is where water thins, where salts are diluted and then concentrated again, where roots test the ground and retreat if conditions turn too sharp. A small bird lifts from the mud nearby, almost unnoticed, until it moves. Its flight is low and quiet. It had been standing beside a shallow depression no wider than a basin, likely searching the damp edge for insects or minute aquatic life left by recent moisture. That is another lesson of this place. The boundary between wet and dry does not need to be dramatic to matter. A puddle only an inch deep can alter who arrives. For insects, it is a world. For a bird, it is a meal. For the sediment, it is another chance to settle, crack, and preserve. The depression itself carries a thin crust around its rim. Inside, the center remains darker and smoother. That pattern comes from retreating water. As the puddle shrank, evaporation worked strongest at the edge, where the water was shallowest and warmed fastest. Dissolved salts were left in a ring. Fine particles settled in the middle. So the basin repeats itself in miniature, one small hollow echoing the larger pan beyond. You continue along the perimeter, and the ground begins to alternate between firmness and softness. On one patch, the surface feels packed and dry. On the next, your step presses into a skin over damp sediment beneath. This matters because the margin stores moisture longer than the open pan. Below the sun-whitened top layer, water can remain trapped in the fine grains, shielded from direct wind and heat. That hidden dampness sustains more than plants. It also supports the small invertebrates and microorganisms that respond quickly when conditions shift. Most of them are never seen directly in a walk like this, but their presence is written into what gathers above them. Bird tracks, a slight stain in the mud, a brief shimmer of insects over still water at sunrise. These are the visible signs of an unseen layer of activity. The pan's edge is full of such indirect evidence. There is a place where tiny paired prints run in a short, uncertain line, then stop at a crack. The animal may have crossed at dawn, when the crust was cooler and firmer. Now the marks begin to soften under warming air. A little farther on, there are hoof impressions pressed deep enough to hold shadow. Those would have been made when this patch was wetter, perhaps after shallow water withdrew, but before the clay fully tightened. The sequence is clear enough. Water spreads, ground softens, animals cross in search of fresher forage on the margins. The sun rises. The mud dries around the impressions. Later, salt outlines them, and wind begins to blur what remains. Nothing dramatic has to happen for the surface to become a diary. The vegetation strengthens almost without your noticing the exact moment of change. First, there are scattered grass tufts. Then, low, salt-tolerant shrubs appear, each separated by bare ground. Beyond them, where the surface rises just slightly, the soil loses some of its white glare and takes on a more earthly brown. That color shift is subtle, but it marks a real change in salinity and texture. The higher ground is flooded less often. It is leached differently by rain. It receives wind-blown sediment from the pan, but does not remain under mineral-rich standing water long enough to harden into the same crust. Here, roots can persist longer, and where roots persist, more life follows. You can feel the whole landscape breathing in a seasonal rhythm, not with lungs, of course, but with expansion and contraction. In the wetter part of the year, water advances over this boundary, flattening distinctions, turning the edge reflective. Later, under sun and dry wind, the mirror breaks apart. Mud reappears. Salt returns. Plants resume their patient hold where they can. Then the next season revises everything again. This is why the margin matters so much. It is the place where change first becomes visible. On the open pan, transformation can seem abstract until water arrives. At the edge, the evidence gathers early. The first softening, the first bloom of algae in a shallow depression, the first insects, the first birds tracing the wet ground, the first thin green in the grasses. A low channel crosses your path, almost level with the surrounding mud. If you are not looking for it, you might take it for a random dip, but its shape gives it away. It is longer than it is wide. Its floor is smoother, its sides are only barely defined, yet enough to guide runoff during rain. This is how water often reaches the pan, not through deep riverbanks or dramatic streams, but through shallow drainage lines that spread, branch, fade, and reappear across the plain. During dry periods, they are nearly invisible. When rain falls elsewhere in the catchment, they become pathways. Because the land here is so gentle in slope, water can move slowly over broad areas. It does not always cut strongly downward. Often it simply chooses the lowest available route and follows it until evaporation or absorption interrupts the journey. That means distant weather has a long, soft influence. A storm far from where you stand may send runoff into these channels. Hours later, or days later, a depression here will darken. Then another. Then a thin sheet of water may gather across a much wider part of the margin. This delay gives the basin an unusual kind of connection to the wider landscape. What happens here is often decided elsewhere first. The pan listens to rainfall beyond its own horizon. Along the shallow channel, the sediment is different again. It is finer in some spots, more mixed in others, as if each recent flow sorted its contents according to speed. That is exactly what happens. Moving water carries a range of particles, from fine clay to slightly coarser silt and sand. When flow slows, the heavier grains settle first. The finest material drifts farther before dropping out, so each pulse of runoff arranges the channel floor in a fresh, almost invisible sequence. Over time, those sequences build the subtle texture of the margin. The result is that one patch may crust over quickly after drying, while the next remains friable. One hollow may grow a clean mineral rim. Another may turn to sticky mud. These differences then feed back into life. Some insects favor shallow, temporary pools. Some birds probe soft sediment. Some plants exploit slightly coarser, better drained patches. The ecology is quiet but exact. Near the channel's edge, a film of dry algae has left the mud with a faint olive-brown cast. It is not bright enough to call attention to itself, but if you let your eyes rest there, the color deepens. This is one of the calmest kinds of abundance. Microscopic, temporary, and spread in a layer so thin that it almost disappears when dry. When water returns, sunlight enters the shallows, and these organisms respond quickly. They use warmth, minerals, and dissolved nutrients in the water. Their growth may be brief, but while it lasts, it changes the chemistry around them. It also provides food, directly or indirectly, for other small life. So even a muted stain in the mud can mark the beginning of a chain. Water arrives, algae bloom, invertebrates feed, birds notice. Tracks appear, then heat increases and the sequence contracts again. A dragonfly passes low, bright for a second, then gone. Its presence is almost enough to make the margin feel lush, though it is not. That is another quiet trick of temporary wetlands. A few moving creatures can make a sparse place seem suddenly full, but the fullness here is never dense. It remains open, airy, widely spaced. The life of the pan's edge respects distance. There is room between each event, room between each plant, room between each bird call, room between water's arrival and water's leaving. The sun is higher now, and the sharpness of the early light has softened into a fuller brightness. That broader illumination reveals more of the pan's outer shape, What from the center looked like a simple rim now opens into shallow aprons of mud and grassland, with isolated patches of whitened soil extending inland like old waves. These are signs of where saline conditions have pushed outward before. At times, standing water or mineral-rich moisture has reached farther onto the margin. As it evaporated, salts accumulated in the upper soil. Later rains may have diluted some of that load, allowing plants to return in places. But the old influence remains legible. The land keeps the memory of past spread. That memory is especially clear where vegetation grows in bands. One belt is nearly bare. The next carries sparse grasses. Beyond that, shrubs become more common. This pattern can arise from tiny changes in elevation, soil grain size, and the depth to which salts have concentrated below the surface. Plants are not only responding to what lies above ground, they are responding to the chemistry hidden in the soil profile. A root reaching downward may meet moisture, or it may meet salinity too intense to tolerate. The landscape's limits, then, are partly invisible until life traces them. You crouch near a patch where white crystals feather through dark mud like frost. This is one of the clearest places to understand capillary action, though there is no need to rush the term. The process is patient. When the ground below remains damp, water can rise upward through very fine spaces between sediment grains. It carries dissolved salts with it. At the surface, under heat and moving air, the water evaporates. The salts remain. Given enough time, repeated rising and drying produces these pale blooms on the mud. What looks like a surface deposit is really a conversation between deeper moisture and open sky. That matters because it explains why the margin can remain chemically active even after visible water has gone. The sun may have removed the last standing pools, yet beneath the crust, moisture still migrates. Salts still move. The next few warm days may whiten a patch that looked ordinary this morning. Later, a light rain may soften it and pull some minerals down again. Nothing here is truly static. Even dryness is busy. A few steps on, the ground bears another kind of evidence. The hoof prints are fresher here, crossing from vegetated margin toward the pan and back again. Animals use these transition zones because they gather resources unevenly. After rain, the edges can offer new growth, softer ground, and temporary water. As conditions dry, the same places harden and quiet. But the records remain for a while. A print in damp clay can last longer than a sound. A track line can outlive the visit itself by many days. This gives the margin a gentle sense of layered time. You are not only seeing what is here now, you are seeing where things passed. The openness helps with that. There are few shadows to hide the marks, few obstacles to interrupt the reading. The whole place behaves almost like a sheet where process writes directly. Still, the script is not only about movement across the surface, it is also about what the surface allows. At one of the lowest points, a cluster of tiny flies skims over wet mud. The moisture is hardly visible except as a darker sheen. Yet that is enough. Where there is a little water and a little organic matter, small lives gather quickly. That gathering can seem out of proportion to the amount of wetness present, but in arid landscapes, slight advantages matter greatly. A patch that stays damp for one extra day becomes a center. By afternoon, the sheen may be gone. The flies will disperse. The mud will tighten and crack. Still, for a few hours, the edge has hosted another brief concentration of life. The same pattern repeats across scales. A large flood changes the whole pan. A shallow pond changes a small depression. A thin, damp strip along a channel changes only a few feet of ground. Yet each event matters to the organisms tuned to it. This is one reason temporary systems can feel so alive without ever becoming crowded. They are made of windows. Windows of water. Windows of softness. Windows of food. Each opens and closes in its own time. The margin is a place where many of those windows overlap. As you move farther along, the basin behind you begins to lose some of its glare. The eye adjusts. Where once it seemed an undifferentiated white expanse, Now it appears segmented by tonal bands, depressions, and old shore traces. That is one of the gifts of staying in a landscape long enough. Apparent emptiness resolves into structure. And once you have learned the edge, the center changes too. You understand better why one area dried sooner, why another kept bird prints, why a pale crust thickened in one direction and broke in another. Knowledge here does not interrupt quiet, it deepens it. The air has warmed enough now that scents begin to rise from the ground. They are faint: dust, dry minerals, a trace of damp clay where mud still holds moisture under the top skin. These smells would be easy to miss in a place with stronger vegetation. Here they feel unusually clear because so little else competes with them. The basin speaks in low concentrations, even scent arrives thinly. A breeze passes over the grasses and reaches the pan. At the edge, the movement is audible as a light brushing through stems. Out on the salt, it becomes nearly silent again. That difference gives the margin another character. It is not loud, but it is less mute than the open basin. Plants catch wind and turn it into sound. Insects turn warmth into motion. Birds convert shallow water into calls. The pan's edge is where stillness begins to articulate itself. You follow a broad curve where the mud darkens, and ahead the land dips almost imperceptibly. This lower sweep would be one of the first places to shine after rain. Because the slope is so slight, even a modest amount of water could spread far before deepening. That geometry is essential to Etosha. The basin does not need much inflow to appear transformed. A thin sheet over a huge area is enough, but before that wide mirror forms, the edge usually changes first. Here, the first reflective shallows gather. Here, microorganisms wake. Here, the ground records which route the incoming water chose. A line of finer sediment traces that route already. It bends around a raised patch, then fades into the broader mud. This is old evidence, not from this exact morning, but from some recent wet period. The flow was weak enough that it left no carved bank, strong enough, though, to sort the surface and leave a path legible after drying. Again, the basin shows its preferred style. Nothing is exaggerated. The clues are small, but they are enough. Now the relationship between geology and life becomes easier to hold in one view. The shape of the ground governs water. Water governs salinity. Salinity and moisture govern where organisms can feed, grow, or rest. Those organisms then add their own traces: roots, tracks, films, droppings, eggs, disturbed sediment, which influence the next drying pattern in slight ways. The system is not large because each part is dramatic. It is large because each part keeps touching the next. A low shrub leans over a patch of bare soil, and beneath it the crust is broken into finer pieces than the open ground beside it. Shade has slowed evaporation here, at least a little. Wind has been softened. Organic debris has collected. One plant has altered a circle of earth around itself. Multiply that by every root and stem on the margin, and the edge becomes a field of microclimates, each one subtle, each one consequential. That complexity does not compete with the pan's spaciousness. It lives inside it. You can stand in a place that feels almost empty and still be surrounded by process. That is one of the most calming truths of landscapes like this. Nothing needs to hurry in order for much to be happening. Far overhead, the sky has lost its dawn delicacy and settled into a clear, strengthening blue. Against it, the margin looks even flatter. But on the ground, the detail only grows. There are pellets of dried mud rolled by beetles. There are minute mounds where sediment has heaved and broken. There are the polished surfaces of places briefly underwater, now dulling as they dry. Each one is a direct result. Water was here, then it was not. Heat followed. Wind followed. Life passed through. The result is this layered quiet. You come to a place where the pale mud opens into a broader seasonal flat beyond the immediate pan. Here the grass is more continuous, though still sparse enough that the sky and ground dominate the view. During wetter periods, this zone can hold broad, shallow water. before it either evaporates or drains farther into the basin. Because the water is fresher here at first, and often less saline than the pan's center, different communities of organisms can take advantage of it. Some plants germinate rapidly, insects breed, birds forage in the temporary abundance. Then, as water stands or retreats, salinity may rise again in isolated hollows, creating tiny internal gradients within the same margin. So even the flooded edge is not one environment. It is many, side by side, sorted by depth, duration, and chemistry. That is why the arrival of water does not simply make the basin wet, it rearranges its possibilities. A shallow pool reflecting the sky may look simple, yet if it lies on slightly fresher ground, one kind of algae may dominate. A few yards away, in a saltier hollow, another community may take hold. Tiny crustaceans may flourish in one pool and not the next. The birds moving between them respond not to scenery, but to these differences in food and chemistry. And because those differences can be tasted and sensed by living things long before they can be seen by us, the flooded margin begins to sort itself into feeding grounds almost as soon as the water arrives. A bird stepping through a pale pool is not moving at random, it is reading depth with its legs, softness with its feet, and abundance with each small pause of its beak. What looks like stillness from a distance is full of these quiet decisions. The shallows are only a few inches deep in many places, yet they change the scale of the world completely. The sky, which a moment ago sat high above the pan, now lies across the ground. Clouds drift below the level of your knees. A breeze passes, and the reflected blue trembles into silver bands. The basin has not become full in the old sense of a deep lake. It has become something more delicate than that. It has become a mirror spread thinly over clay. Where the white crust has dissolved, the mud below darkens into cool grey and brown. At the edges of those newly wet surfaces, soft rims begin to form. Some are smooth and clean. Some are fringed with tiny foam-like salts, where the first evaporation starts its work again, even while water still remains. That is one of the strange, calm truths of a place like this. Flooding and drying do not wait politely for one another. They overlap. The moment water settles, the conditions for its leaving have already begun. Still, for now, presence outweighs retreat. The soundscape changes before the eye fully accepts the transformation. When there is open water, however shallow, it holds and returns small sounds differently. Bird calls carry across it. A light wind creates a skin-soft hiss as it moves over the surface. Even your own step near the edge seems quieter because damp ground receives sound instead of scattering it. The pan remains spacious, but it is no longer mute. A flamingo stands in the middle distance, pale against the pale water, almost unreal until it shifts its weight. Then another resolves behind it. Then a loose line farther out, each one separated by long, calm intervals of space. They are here for reasons as exact as the algae stains you saw earlier. Shallow saline water can support the microscopic life and tiny invertebrates they feed upon. The water does not need to be deep. It only needs to last long enough and carry the right chemistry. In some seasons, that is enough to turn wide areas of Etosha into feeding habitat. Not all at once, and not evenly. One reach of the pan may remain bare while another holds birds in quiet concentration. The difference can depend on inflow route, timing, salinity, and the depth of water left by a very slight hollow. So you move along the edge of the flooded spread, and the ground itself begins to show the recent change. Fresh tracks cut across softening mud. Some enter the water and vanish. Others emerge from it, rimmed in drying crystals, where each print held moisture a little longer than the ground around it. The old surface has been rewritten. Earlier bird marks, hoof prints, and brittle plates have softened under the sheet of water. Now a new page is being laid down over them. This is what makes the flooding feel irreversible within the day. Once the crust dissolves and the mud opens, the pan cannot become what it was at dawn. It may dry again later. It may whiten again. but the specific arrangement of that earlier morning is gone. A low swell of breeze moves across the flooded flat, and for a moment the entire mirror carries fine ripples from one side to the other. The effect is almost too broad to follow. Light breaks into moving scales. The reflected clouds shiver apart. Then the water settles once more, and the sky reforms on the ground. Because the pan is so shallow, even small winds can redraw the surface instantly. Yet those changes remain gentle. Nothing here heaps into waves, nothing rises high. Motion stays close to the skin of the water, as if the basin prefers quiet transformations. Near one of the margins, a thin pink tint appears where the water lies over pale sediment. It is not bright enough to call attention to itself unless you let your eyes rest there. That color can come from microscopic life adapted to salty, sunlit shallows. As evaporation proceeds and salinity shifts, different communities of algae and tiny organisms can become more prominent. Some bring a green cast, some an amber-brown tone. In certain conditions, the water leans softly toward rose. The chemistry of the pan is painting in restrained colors. This is why the flooded basin never looks simply blue and white. It holds a spectrum muted by light, minerals, suspended clay, and life too small to separate with the naked eye. The result is a world of very quiet color: soft silver, weak gold, pale pink, a little green near the shore, gray-brown under the thinnest water. Each shade tells you something about depth, sediment, and salt. A few waders move through a narrow feeding lane where the water has collected above dark mud. They stop often. Their beaks touch down. They advance again. This pace is important. In temporary wetlands, food is distributed patchily. A bird may find rich feeding in one strip only a few feet wide, because that is where invertebrates are most concentrated, or where the mud is soft enough to probe. Just beyond it, conditions may be less useful. The birds map these differences with patient movement. From a distance, they seem to be drifting. Up close, each step is informed. The pan itself helps create those feeding lanes through slight topography and the behavior of water under heat. As floodwater enters the basin, it does not maintain one uniform depth. It spreads over ridges and hollows inherited from old drying patterns, sediment deposits, and subtle underlying relief. Some places stay exposed. Some lie under a film so thin that sediment shows through clearly. Some retain a little more depth, enough to resist immediate heating and concentration. That means organisms experience the same flood differently depending on where they settle. The consequence appears quickly. Birds gather in lines, arcs, and scattered clusters that mirror invisible gradients beneath them. A pool near your feet holds no birds at all, yet it is not lifeless. A few tiny circles disturb its surface. Some may be insects touching down, some may be air escaping from mud as the water warms. Below the surface, fine particles remain suspended, making the shallows look almost milky in places. That suspended load matters. Clay keeps the water from becoming perfectly clear. It also influences how light penetrates, how heat is absorbed, and how quickly particles settle back out when movement stops. Once the wind drops, the finest material slowly drifts downward. Then the pool brightens at the top and darkens below. Stillness becomes visible. A long, thin band of whiter material marks where the old crust is dissolving at the edge of the flood. It curls around the water like a shoreline, though the drop in level may be barely measurable. There is a softness to this edge that deep water never has. No abrupt bank, no strong line between one world and the next. Only a transition from damp clay to reflective film, then to a slightly thicker spread of water farther in. This softness is one reason the flooded pan feels so calm. The landscape does not divide itself sharply. It blends. Farther out, where the mirror broadens, flamingos stand in such shallow water that their reflections seem longer than their bodies. The image reaches downward into the white brightness, then a ripple bends it apart, then stillness restores it. That repeated making and unmaking of reflections becomes one of the day's quiet rhythms. Nothing lasts in a fixed form for long. and yet nothing feels hurried. Even change keeps a slow pace here. Flamingos are often imagined as vivid and noisy, but at this distance, in the flooded pan, they belong to the hush. Their pale bodies echo the color of the basin. Their movements are measured. They feed by filtering small organisms and particles from the water, often by sweeping the bill in shallow arcs. That feeding style suits broad saline flats remarkably well. The water does not need fish or aquatic plants in abundance. It only needs the right small life in the right density. And where chemistry allows that, birds arrive. A little farther along the margin, you come upon a place where runoff entered more recently. The water there carries a slightly browner tone. That suggests more suspended sediment and perhaps fresher inflow not yet fully mixed with the salts already in the basin. Where incoming water first reaches the pan, it can briefly dilute the surface layers. Later, as sun and wind remove water, salinity rises again. So the chemistry is not fixed even across one shallow spread. It changes over time and from place to place. Early on, one pool may be comparatively fresh. Days later, the same pool may become strongly saline. The organisms that persist there must either tolerate that shift or complete their brief life stages quickly. Temporary wetlands often favor such flexibility. Some microscopic organisms can bloom fast. Some tiny crustaceans produce resistant eggs that endure dry periods in the sediment, then hatch when water returns. This is part of the hidden continuity of the pan. Even when the surface looks empty, the next season may already be waiting in the soil. A dry basin is not a dead one. It is a stored one. The sheet of water reaches across a wider reach now, enough that the old white floor seems broken into islands and bars. Those bars are simply slightly higher patches where the flood remained thinner or where crust persisted a little longer. But visually, they change everything. The eye can now trace channels of reflection between pale emergent ridges. The pan begins to resemble a map in motion, and because the water is so shallow, these shapes can change over a day as wind nudges the surface and evaporation lowers it grain by grain. A single afternoon of heat can reveal mud on one rise while another still gleams. The sky above is broad and clean, and the pan answers it with almost complete honesty. When a cloud passes, its shadow glides over the mirror and turns one section from silver to pearl. When the cloud moves on, brightness returns. This shifting light affects more than appearance. Shading can slightly cool the shallow water. Sun can warm it quickly again. Temperature, in turn, influences evaporation rates, oxygen levels, and the activity of small organisms. Even the passage of a cloud enters the chemistry. This is how responsive the flooded pan is. It is a system of small volumes under large sky. The flamingos have been joined now by other birds. Some are slender waders pacing the edge. Some float briefly in places where the water deepens by only a few more inches. A few move in loose groups, though the overall impression remains spacious. The pan never feels crowded. Its scale absorbs every gathering. This helps preserve the stillness even at the emotional high point of the day. There is more life now than there was at dawn, more sound, more motion, more reflected light. Yet the essential quiet remains intact. It is simply a fuller quiet. You pause at a shallow inlet where the mud underwater carries faint ripple marks. These are not wave ripples in the ocean sense, but delicate patterns shaped by wind moving the thin surface layer over soft sediment. Because the water is so shallow, the floor records disturbances easily. A little breeze, sustained for an hour, can leave texture in the mud. Later, if the water withdraws without erasing it, the marks may dry into place. Then the next flood may cover them, soften them, or preserve them beneath a new layer of settled silt. The basin keeps archives at very fine scales. One afternoon can become a pattern in clay. Nearby, a border of tiny crust fragments and organic debris has gathered against a low rise. This is where drifting material comes to rest when the slightest current or wind-driven surface movement slows. Even in very calm water, transport still happens. The pan sorts what enters it, Light fragments collect in one zone, finer mud settles elsewhere, dissolved minerals remain invisible until the water thins enough to leave them behind. The whole flooded basin is working quietly toward its next dry form. That future is already present in the arrangement of what the water holds. A deeper look into the shallows reveals how little the water needs in order to become productive. Sunlight reaches all the way down, because there is almost no down to speak of. Heat enters quickly. Suspended sediments carry nutrients. Dissolved salts shape which organisms can thrive. Microscopic algae begin to use the available light. Bacteria cycle organic matter. Tiny invertebrates graze, filter, or drift through this brief abundance. Then birds connect these minute processes to the visible landscape. They do not create the productivity, they reveal it. A flamingo lowers its head and sweeps. Its bill is specialized for filtering food from water and mud. In broad terms, it separates useful particles and organisms from the rest. That means its presence tells you something about the scale of life below the reflective surface. Not large prey. Not dramatic hunting. A field of tiny abundance spread thinly but widely enough to matter. The flooded pan is built on such scales. A little more water there, a little more salinity here, a bloom too small to see clearly. A feeding flock that appears only where all those conditions overlap. The emotional effect is gentle, but the process beneath it is exact. You follow the margin toward a place where the water forms a longer, brighter strip. The white floor underneath gives it a luminous quality, as if the pan were lit from below. That effect comes from the combination of pale sediment, mineral crust, and shallow depth. Light enters, strikes the bottom, and returns quickly. This makes the flooded surface seem lighter than a deeper pond would. It also means that any darker band, mud, algae, tracks, or shadow, becomes especially legible by contrast. The pan is using brightness to reveal fine differences. A line of tracks crosses the flooded edge and continues beneath the clear shallows for a few paces before vanishing into soft sediment. That sequence tells a recent story. An animal crossed while the water was already present, but while the mud was still firm enough near the rim to keep impressions. Farther in, the substrate became too soft or the water too stirred for the marks to remain distinct. Again, absence is useful. It tells you where conditions changed. The flooded pan is full of these partial narratives, not complete stories, but enough to understand sequence. Water arrived, ground softened, birds came, wind roughened the surface, sediment settled, evaporation began. As the sun climbs, the first very slight retreat becomes visible at some edges. Not the drying of the whole flood. Not yet. Only a narrowing at the thinnest margins, where moisture disappears from elevated spots first. This uneven retreat is one of the most important habits of the basin. Water does not leave as a uniform sheet. It breaks apart according to depth, exposure, and sediment texture. Raised patches brighten, shallow rims harden. Tiny pools disconnect from one another. A continuous mirror becomes a chain of reflective fragments. That process will matter later. For now, it simply introduces the idea that flooding already contains its own future geometry. In a small, sheltered hollow, the water has taken on a greener cast than the main flooded plain. Perhaps the mud there is richer in organic material. Perhaps the depth and stillness have allowed a different concentration of microscopic growth. The exact cause may be subtle, but the result is clear enough. This pool is chemically distinct from the one beside it. A bird notices first. It walks directly to the edge, pauses, feeds, and remains there longer than it did at the clearer water nearby. The flooded pan is not one habitat. It is an archipelago of conditions connected by a thin skin of water. That is why the arrival of water feels like a midpoint in the life of the landscape. The basin has shifted from stored memory to active expression. What was written in old shorelines, crust bands, and dry algae stains has become visible process again. The pan is showing, not only telling. The old lake is not back in the sense of permanence, but its logic has returned. Water has spread into the low places. Minerals are dissolving and moving. Life is redistributing itself. The basin is once again organizing around shallowness. A subtle smell rises from the warm edge of the flood. It is clean, mineral, a little earthy where mud is exposed. There is no richness of dense wetland vegetation here. No heavy sweetness, only the scent of heated water, clay, and dissolved salts. That restraint suits the scene. Everything in Etosha tends toward openness. Even when the pan holds water, it remains an uncluttered world. The horizon stays wide. The birds are spaced apart. The pools breathe. Nothing closes in. Because the water is so level with the land, the boundary between atmosphere and surface feels especially thin. Heat shimmers above the reflective shallows. Clouds seem to settle into the pan rather than hover above it. Birds walking through the mirror appear to move through the sky. This merging of layers changes how distance behaves. A flock farther away may look suspended in light. A raised shore can dissolve into brightness and reappear. The flooded pan becomes harder to measure and easier to inhabit quietly. You no longer feel that you are looking across a flat. You feel that you are standing inside a broad field of reflection. At one point, the wind drops almost completely. Then the basin becomes extraordinarily still. Reflections sharpen. Bird legs become vertical lines doubled in water. Even the small irregularities on the mud floor beneath the shallows are visible. Moments like this reveal just how little movement the pan requires to feel alive. No large wave, no sweeping event, only suspended light, soft feeding motions, and the slow drift of cloud shadows over a temporary mirror. Yet this stillness is not inactivity. Below the calm skin, evaporation continues to lift salts toward the surface where water is thinnest. Suspended particles continue settling. Microscopic life continues feeding, dividing, or drifting. The chemistry does not sleep simply because the landscape looks restful. It keeps adjusting. That hidden adjustment becomes the next quiet thing to notice. Along the edge of a receding puddle, a lacework of fresh crystals begins to appear, not large enough to sparkle from a distance, but definite when you kneel and let your eyes settle. Their formation depends on concentration. As water leaves by evaporation, dissolved minerals approach the point where they can no longer remain fully in solution. Then they begin to precipitate, first along margins, on small irregularities, around grains of mud, or in thin bands where the water film is especially shallow. The pan is drawing new boundaries in salt. A soft gradient of pink deepens in one broad section of water as the afternoon light shifts. The color is not dramatic. It feels almost breathed into the basin rather than painted on it. In saline environments, such tones can emerge when certain microorganisms become more abundant under strong sun and increasing salt concentration. Their pigments help them function in harsh, bright conditions. To us, the result is a delicate tint spreading through the shallows. To the organisms, it is simply life adjusted to chemistry. The basin turns adaptation into color. This is the point where the flooded mirror begins to open into its smaller workings. The birds remain visible and graceful. The water remains reflective. But now your attention starts to sink below the surface impression and into the thin, busy layer where salt, mud, sunlight, and microscopic life are negotiating every inch. A white pan holding shallow water can seem simple from far away. Up close, it is almost precise beyond belief. A fraction more wind can redistribute suspended clay. A few hours more sun can change the concentration of dissolved minerals. A slightly deeper pocket can stay cooler and less saline than the shelf around it. Then the organisms respond. Then birds respond to them. Then the drying pattern changes in consequence. This is how a vast basin can be governed by details small enough to fit on a fingertip. You move toward a low area where the water is quiet enough for the bottom to show through clearly. The mud there is coated in a faint brown-green film. In that thin film, a great deal of the pan's quiet work is being done. The color comes from microscopic organisms, especially algae and bacteria, spread in a layer so slight it almost seems imagined. Yet, it is real enough to change the surface. It binds fine particles together, it traps a little moisture, it alters how light rests on the mud. And when birds feed here, they are responding to that hidden foundation. The film is also part of the reason some patches dry differently from others. A bare stretch of clay may pale quickly under the sun. A stretch coated with microbial growth may darken longer, holding heat and dampness for just a little more time. That small delay matters. It changes when salts begin to crystallize. It changes when insects gather. It changes when a feeding bird decides to stop or move on. So the smallest living layer beneath the water helps guide the larger visible pattern above it. If you look carefully along the edge of this low area, you can see where the film thickens. The water there has been shallow, still, and bright long enough for growth to concentrate. A few feet away, where the surface was more often stirred by wind, the color breaks apart into faint patches. That difference tells you how sensitive the flooded pan is to movement. Not dramatic movement, just a light breeze crossing open water for an hour or two. Stillness allows one kind of settling. Agitation encourages another. Even in the same afternoon, one pool can become more chemically concentrated while another remains slightly diluted. The evidence stays low to the ground. A faint tint, a dull sheen, a new fringe of salt, a line of birds choosing one side rather than the other. All of it belongs to the same sequence. Water arrives carrying dissolved minerals and suspended sediment. Sunlight enters the shallows. Microscopic life responds. Wind redistributes the thinnest layers. Evaporation concentrates what remains. Then the surface begins sorting itself once more. You move along the margin of the low area, and the mud under the water changes from smooth to softly stippled. Tiny raised spots interrupt the surface in no obvious pattern. Some are likely grains or small clumps of sediment where crystallization has started. Some may mark bubbles that lifted from the mud and broke. Some could be the first roughness left by organisms growing across the substrate. What matters is not any single bump. It is the fact that the floor is becoming textured again. The flood did not erase the basin into sameness. It suspended it for a while. Now difference is returning. At the edge of one shrinking pool, a narrow white border has formed with remarkable neatness. It is no wider than your hand, yet it curves around the water with the precision of a map line. This is where dissolved salts have become concentrated enough to leave the water and join the ground again. The process sounds simple because it is simple. As water evaporates, the same amount of mineral is held in less liquid. Eventually, the solution becomes too crowded. Crystals begin to form. Because the thinnest water often evaporates fastest, the edge becomes a favored place for this first visible return of salt. The border matters because it shows the flood already retreating in stages, not leaving all at once, leaving selectively. A slightly raised patch dries and brightens. A lower patch remains brown and reflective. The boundary between them sharpens. Then the boundary itself gathers crystals. The basin redraws its own contours out of chemistry. A few feet farther on, there is another reveal. The water in one shallow lane is tinged, not pink, not green, but a muted amber. It is the kind of color that would go unnoticed in a richer landscape. Here it becomes meaningful. The amber tone may come from suspended fine sediment, from dissolved organic material, or from another shift in microbial abundance. Whatever the exact mix, the point remains the same. The flooded pan is not uniform. It is made of countless slight departures from uniformity, and every departure has consequences. One lane warms faster, one becomes cloudier, one concentrates salts more quickly, one attracts a different kind of feeding pattern. Seen from high above, these variations would likely form wide, soft mosaics. From the ground, they appear in pools, strips, fans, and rims. The basin keeps dividing itself into temporary neighborhoods. A line of flamingos stands well out on the open mirror, but nearer the edge, smaller birds are now more active. They pace between exposed mud and inches-deep water, then stop at intervals that are oddly regular. This is not ceremony. It is simply that food is concentrated at certain depths and in certain sediment textures. Where water is too deep, small waders may not reach the most productive layer. Where mud is too firm, probing becomes less effective. Where salinity rises too far, one food source may decline and another take over. So the birds spread themselves according to conditions too subtle to draw with a finger, but plain enough to read with a bill. As afternoon matures, the light becomes stronger and flatter. Reflections remain, but the eye now sees through them more easily. The bottom comes forward. The cloudy edges of one pool reveal soft swirls where a recent footstep stirred silt. Another shows clear water over a hardening floor, the beginning of a new crust not yet visible, but implied by firmness. The basin is entering a different phase. The flood is still present. The mirror is still broad. But the hidden chemistry is moving to the foreground. You can sense it in the way the waterline changes by inches. You can see it in the crystals forming on mud. You can infer it from the color shifts and the birds' choices. The quiet drama now is concentration. This part of the story belongs to evaporation. In northern Namibia, heat does not need to announce itself loudly. It simply persists. The air grows warmer. The open sky remains clear. The shallow water offers a vast surface for loss. Because the flooded pan is so broad and so thin, it is especially vulnerable to this steady upward pull. Water molecules leave from the surface into dry air. As they go, the dissolved salts stay behind. If more water flows in, the balance changes. If not, the water body gradually becomes more mineral-rich. This is the central rhythm of the pan. It is never merely filling or drying, it is concentrating. That concentration changes everything. At lower salinities, a wider range of microscopic life can function. As salt levels rise, only more tolerant organisms persist. Some algae flourish for a time in moderately saline water, then fade as concentration increases. Other microorganisms become more prominent later, when the water turns harsher for most life. Their pigments can shift the color of the pool. Their activity can change the texture of the surface film. And because many invertebrates depend on these smaller lives, the food web reorganizes with the chemistry. A shallow pool is therefore not one habitat through time. It becomes several, one after another. This explains why the flooded pan can feel different from morning to afternoon, and different again over several days, even if the water still appears to be there. The visible shape may remain nearly the same, but inside that shape, dissolved minerals are rising in concentration. Microscopic communities are changing. Soft mud is hardening at one edge and staying open at another. The pan is never at rest in the chemical sense. Restful to stand in? Yes, but still active in every inch of water. A narrow breeze crosses from the grassland and skims the shallows. It drives a soft line of ripples over one pool, but leaves a more sheltered hollow almost untouched. That shelter may come from barely perceptible differences in relief, or from a low margin of firmer ground. The result is that one pool mixes while the next remains stratified in a loose, temporary way, not sharply layered like a deep lake, more like a tendency. The upper inch warmed by the sun, the lower mud releasing salts and nutrients into the water just above it. Where wind stirs the pool, those differences are blended more quickly. Where stillness persists, local chemistry can intensify. So even the shape of the ground around a puddle affects what develops inside it. You kneel near a drying edge and see tiny crystal needles projecting from the mud. They are almost too delicate to describe as a crust. They look more like frost returning in a hot place. This is one of the quietest transformations in Etosha. A pool that was recently open water begins to write itself back into white, not by draining away into a visible channel, not by sinking underground in any obvious manner, but by rising into air molecule by molecule, while minerals gather below into geometry. The mud beneath is still damp. The center of the pool still reflects the sky, yet the edge is already becoming solid. This overlap is important. The pan's phases do not replace one another cleanly. Wet and dry coexist in narrow bands. Water and crystal share the same shallow slope. Life and mineral process occur together. This is why the basin feels layered rather than episodic. Nothing entirely waits for something else to finish. A closer look at the crystalline reveals irregularity within order. Some parts are smooth and continuous. Others break into little rosettes and scales. The exact form depends on concentration, temperature, the type of dissolved minerals present, and the shape of the sediment surface where growth begins. Sodium chloride, the familiar salt of many pans, is only part of the story in places like this. Other minerals can be involved, especially where evaporation cycles repeat through time and where inflowing waters carry varied dissolved loads. To the eye, the main impression is still one of whitening, but within that whitening there are choices made by chemistry. One patch hardens glossy and thin, another becomes powdery, another takes on a brittle skin over softer mud beneath. The returning white is never identical everywhere. A small flock of waders lands on a newly exposed mud shelf. Only an hour earlier, this area was under a thin cover of water. Now it is soft but accessible, and that timing matters. As water retreats, organisms concentrated in the shallows can become easier to reach. Invertebrates may be trapped in films or pooled in tiny residual pockets. The exposed mud may still be wet enough to probe, so a receding edge often becomes a feeding zone. The birds know this long before the eye fully appreciates the retreat. Their arrival is evidence. They are following the geometry of evaporation. The pan is always teaching through consequences. If the waterline shrinks unevenly, birds gather unevenly. If one part of the basin holds a bit more depth, it remains active longer. If another dries fast, it becomes a white plate marked with tracks and crystals. A change in chemistry is translated into a change in where feet touch mud. That translation is what makes the place so readable. The visible world is a summary of hidden shifts. Farther out on the reflective flat, the flamingos remain in broader water. Their spacing has altered slightly. A loose cluster has tightened into a line along a shallower contour, where food is evidently favorable. Even at this larger scale, the same principle holds. The birds are tracing topography and chemistry together. They are not arranged by our idea of beauty, though the result is beautiful. They are arranged by depth, salinity, and concentration of tiny life. The flooded pan provides structure, even when it looks almost level. The light begins to show a slight incline toward afternoon, not yet soft, but less vertical. This helps reveal thin bands in the water that were harder to notice earlier. One band shines almost metallic, the next is matte. One carries a pink haze. Another is clearer and cooler. These differences can arise from depth, from microbial films, from sediment still settling, or from minute roughness in the water surface caused by wind. Seen together, they make the pan look brushed rather than painted. It is a landscape of horizontal whispers. At the outer edge of one wide flooded sheet, the old crust has broken into floating flakes. They are very thin, pale fragments loosened when water returned and lifted the brittle surface. Some remain at the margin, some drift a short way before dissolving or sinking into mud. Their presence is a reminder that the flood is acting not only as water on a surface, but as a solvent, entering an older mineral skin. The pan is partly consuming its previous form in order to create the next one. That sounds larger than it looks. What you see is simply white fragments at the edge of brown-gray water. But the implication is deep. Every new flooded season reworks what the last drying season made. No crust is permanent. It is a temporary arrangement, waiting for either wind or water to alter it again. This continual reworking is part of why sediment layers matter so much in the long view. At the surface, each season seems to erase or dissolve the last, yet some portion of each cycle is retained. Fine clays settle and compact. Minerals move downward or remain in place. Organic traces are buried, mixed, or transformed. The archive thickens slowly. The present flood is not only a seam, it is a contribution to future ground. A trace amount of sediment added here. A salt concentration shifted there. A microbial mat thickened for a few days and then dried into the topmost layer. Over many repetitions, these almost invisible contributions build the pan we walk on. A low, warm smell rises where a patch of exposed mud begins to harden. It is the smell of wet earth under sun, lightened by mineral sharpness. Nothing lush about it. Nothing heavy, just a brief signal that water has recently been here. Soon even that will fade as the surface dries further. This is another way the basin marks time. By smell, briefly. By track, a little longer. By crust, perhaps until the next flood. By sediment for much longer still. You continue toward a shallow branch of water splitting around a slightly raised island of old crust. On the higher center, the surface remains bright white and dry. Around it, two narrow channels of water hold different tones. One is brown-gray, clouded with fresh silt. The other is clearer and faintly green. This split provides a simple demonstration of how quickly conditions can diverge. One side may have received recent inflow carrying sediment. The other may be more isolated, allowing particles to settle and microorganisms to multiply. A difference of only a few yards becomes a difference in chemistry and life. The raised island between them keeps the evidence neatly separated. It is like a page torn into columns by a very shallow flood. Here, you can trace the chain with unusual clarity. Slight elevation causes uneven flooding. Uneven flooding causes different residence times for water. Different residence times influence sediment settling and salinity. Those changes alter microbial growth. Microbial growth affects food availability for small animals. Birds sort themselves accordingly. Then, as drying begins, the water edges retreat at different speeds, leaving different crusts. One small rise in the pan becomes the center of several branching consequences. This is how the entire basin works. Scale changes, but the logic does not. A tiny black insect skates across the clearer channel and stops at the edge of a microbial film. In another place, this moment might pass unnoticed. Here it seems to belong to the larger order of things. Life is not abundant in a crowded sense. It is selective, well-placed, and timed to opportunity. The flooded pan is full of opportunity measured in hours and inches. A little warmth, a little water, a little algae. That can be enough. The afternoon air dries further, and the skin of some pools begins to look tighter, almost as if the surface has become thinner, though of course it is only shallower. The mirrored quality remains, but the reflections sharpen at certain angles and disappear at others. This happens because the water film is changing. Where it becomes very thin, the eye starts to compete between seeing the reflection above and the bottom below. The basin enters a beautiful uncertainty. Sky and mud overlap. Clouds seem painted on clay. White crust beneath the water brightens until it is hard to tell whether a patch is dry or only very shallow. This matters for birds as well. What appears as a continuous expanse from a distance may in fact be a mosaic of dry plates, sticky seams, soft pools, and firm mud. A feeding bird testing the surface with its feet is reading information the eye can only guess. The pan asks for close attention. At one margin, the water has left behind a fringe of curled crystals around a bird track. The print itself remains dark and damp at the center. Its edges have whitened first. That tells you the depression held water after the surrounding mud began to dry. Each footprint becomes a tiny evaporation basin. Because it is lower, water lingers there. Because water lingers there, dissolved salts can concentrate and precipitate around its rim. So an animal crossing the pan not only records its movement, it alters the chemistry of the surface in miniature. A basin within the basin. This is one of those details that seems almost too delicate to matter. Yet repeated thousands of times, such disturbances influence texture, roughness, and where later moisture may collect again. The pan remembers even light pressure. Near a broader wet stretch, the water has turned slightly opaque with a milky cast. This can happen when wind stirs fine clay from the bottom, or when very high concentrations of suspended particles remain in place after fresh inflow. The effect is to reduce visibility into the pool and make the reflected sky appear softer. That softness changes heat absorption and the apparent color of the water. It may also influence how certain small organisms function by altering light penetration. So even cloudiness is part of the system's internal sorting. A clear pool and a cloudy pool under the same sun are not the same environment. One of the most calming things about this process is how completely it unfolds without noise. Crystals form in silence, algae spread without announcement, water thins at the edge of a pool so gradually that only comparison reveals it. Birds walk, feed, pause, and move on. Nothing argues with the heat. Nothing resists the wind. The basin accepts each condition and reorganizes itself around it. By now, the flooded mirror of midday has begun to separate into more distinct forms. Broad, shallow sheets still lie across the low center, but their edges are more articulated. Channels appear where before there was only uninterrupted reflection. Mud bars grow brighter. Feeding lines of birds become narrower. The pan is entering its phase of refinement. Water remains, but its boundaries are becoming more informative. You follow one such narrowing sheet toward a place where exposed ground bears the first returning polygons of drying mud. Earlier in the day, this surface was hidden. Now it has emerged, smooth at first, then faintly cracking as shrinkage begins. When wet clay loses water, its volume decreases. If the drying is relatively even, the surface pulls itself apart into polygonal plates. The pattern appears because the stress of contraction needs release. Cracks offer that release. Later, minerals may gather in those openings. Later still, a new flood may soften the edges, erase some lines, and preserve others. So the polygons are both a fresh beginning and a continuation of old habits. They announce that open water is becoming land again. The effect is not sudden. It is almost ceremonial in its patience. First, the sheen dulls. Then the mud surface becomes visible. Then faint lines appear. Then they widen. Then their edges pale as salts crystallize. Finally, the whole patch joins the growing field of reforming crust. At every stage, the pan remains legible. Nothing is hidden for long. A broad white bird feather lies trapped in a drying margin, partly embedded in mud, partly dusted with crystals. It may have fallen hours ago. Already the basin is beginning to preserve it. If the next days remain dry, the feather could be fixed in place by crust long enough to last until wind lifts it, or another shallow flood loosens it. That is how the pan handles visitors and traces. It incorporates them briefly. A hoofprint, a fragment of shell, a feather, a line of algae, all become part of the current surface until conditions change. This ability to hold aftermath is one reason the returning white does not feel empty after water retreats. It feels inhabited by what has just occurred, and because the white is returning over ground that was recently alive with shallow water, every mark now carries a doubled meaning. A bird print is not only a track, but evidence of where feeding lasted longest. A pale rim is not only salt, but proof of how slowly that last film of water withdrew. A dark patch is not only damp mud, but a place where chemistry is still catching up with the sun. You walk farther out again, where the broad surface is whitening by degrees, and the pattern becomes easier to read with each minute. Some sections have already hardened into a thin mineral skin. Others remain soft beneath a deceptive brightness, giving slightly underfoot before holding. That variation matters, because reforming crust does not spread evenly across the pan. It starts where the water was thinnest, or where the wind helped dry the surface, or where slightly raised ground shortened the life of the pool. Then it advances inward from many edges at once. The result is not one clean return to dryness, but a patchwork of phases existing side by side. Here, the crust crackles. A few paces away, mud shines. Beyond that, a narrow lane still reflects the sky. The basin becomes most legible in this in-between state. A broad white field begins to reform near the center of the shallows, but the whiteness is different from the morning's crust. This newer surface is fresher, less compacted, more delicate at the edges. If you look closely, there are places where the crust lies like paper over darker softness beneath. That thin skin forms because dissolved minerals have gathered at the top as moisture escapes. The very surface hardens first. Below it, the sediment can remain damp, so the pan often gives the impression of firmness before the ground has fully completed the change. That is why some patches hold clear prints while others barely register a step. The drying is layered. The first sign of wind's return appears in the finest powder, not yet enough to lift invisible sheets, but enough to creep. Loose grains begin to gather in the lee of a slight ridge, or against the rim of a hoofprint, or along the upturned edge of a salt plate. The movement is almost too subtle to notice while it happens. Yet, after a little while, the evidence is there. One side of a print has become more defined, another has begun to soften with drifted dust, so the records of water are now being edited by air again. That handoff is one of the quiet turning points of the basin. When floodwater is present, it decides the shape of the day. When the surface dries enough, wind takes over the finer work. Not all at once. Only by degrees. First, evaporation draws the white upward. Then crust forms. Then powder loosens. Then the smallest particles begin to travel. The pan does not switch from one state to another. It leans. A line of flamingos remains in the distance, but their reflections have shortened as water depth decreases around them. What was earlier a broad mirror now breaks around their legs into interrupted strips of brightness. Even their presence begins to feel more temporary. The feeding is still calm, but the water that made this reach attractive is thinning. Soon the most productive depth may shift elsewhere. That is often how it goes on broad seasonal flats. Birds do not simply arrive and stay. They follow the moving geometry of suitable shallows. So a flock in one area today may stand farther out tomorrow, or near a different margin, tracing the invisible migration of water across the basin. Near your feet, the exposed mud between two receding pools carries a scatter of tiny holes. Some may have formed from trapped air escaping as sediment warmed. Some may mark the brief activity of invertebrates in the soft ground. Some may simply be where droplets or grains disturb the drying surface. The exact cause of each point matters less than the effect of many together. The mud is not smooth in any perfect sense. It is full of small disturbances, each one a clue that the surface has recently been busy. That busyness is calming here because nothing advertises itself. The pan reveals change only to patient attention. A narrow channel of leftover water runs between reforming crusts like a seam of dull silver. Its edges are sharper now than they were earlier. That sharpening happens because neighboring areas have already passed the threshold into exposed ground. As a result, what remains liquid seems more definite, yet the channel itself is shallow enough that the bottom shows through. There is no mystery in depth here, only in timing. How much longer will this strip remain connected? How long before the center breaks into separate pools? How quickly will the edges whiten compared with the darker lane at its heart? These are the questions the basin keeps asking in practical ways, and each answer appears directly on the surface. The tracks are more numerous now on the returning flats. Some are delicate bird prints, finely spaced, crossing from water to mud and back again. Others are deeper and broader, left by larger animals at the margins where the ground had softened enough to remember them. There are places where one set overlays another, a hoofprint pressed into older cracked mud, then bird tracks crossing the damp bottom of the print, then a mineral fringe gathering at the edge. This layering gives the pan a subtle chronology. First the ground was soft enough for weight, then it remained wet enough to attract smaller feeders. Then it dried enough for salt to precipitate. A single footprint becomes a little basin with its own sequence. If you stand still and let your eyes move slowly, the open white begins to feel almost written over. Not crowded, never crowded, but legible. Long curving drag marks where floating crust fragments were pushed before they settled. Sharp V-shaped prints of waders, the rounded depressions of hooves, fine cracks radiating from places where the mud tightened under a skin of salt. Thin, dark lines where water lingered longer. Everything here is consequence, nothing decorative. The pan's beauty comes from the honesty of process. Late afternoon light starts to lower just enough to reveal relief that midday would flatten. Small ridges stand out more clearly. Shallow basins become visible by shadow rather than only by color. This helps explain another part of the pan's apparent emptiness. At certain hours, the surface hides its own topography and brightness. At other hours, it discloses it. So the same ground can seem featureless at noon and intricately shaped toward evening. The basin has not changed in those hours as much as the angle of light has changed the way your eye can read it. That difference matters when thinking about water. If low evening light reveals a hollow that morning glare concealed, then that same hollow may hold moisture longer than a casual glance would predict. And if it holds moisture longer, it becomes a different patch of habitat. So light does not just alter beauty here, it alters understanding. A dry belt appears ahead, its crust cleaner and brighter than the adjacent ground. That brightness suggests the water there was shallow enough to evaporate quickly and leave a relatively concentrated mineral layer at the top. Beside it lies a grayer strip where the mud likely remained wetter longer, allowing salts to mix back into the top sediment rather than forming a pure crust. This side-by-side contrast gives the pan its broad tonal banding. What seems abstract from far away is really the result of many local histories. One strip dried in thin water over pale substrate, one held muddier water longer, one was stirred by wind. One was sheltered, one received fresher inflow before concentration resumed. Each strip is a memory of a slightly different sequence. A few birds still feed in tiny residual pools left behind by the wider retreat. These pools are important because they briefly intensify what the broader flood had spread out. As water withdraws, organisms can become concentrated in smaller volumes. That can turn the last connected puddles into short-lived feeding centers. The effect is temporary. A day later, those pools may be too saline, too dry, or simply gone. But for the moment, they matter a great deal. This is why the pan's quiet ecology often gathers around endings as much as beginnings. The first arrival of water opens opportunities. Its retreat creates others. A shrinking pool can be as active in its own measured way as a fresh inflow. At one isolated puddle, the rim is scalloped by repeated retreat. The waterline did not fall in a single clean motion. It stepped inward. Perhaps the air cooled one night and slowed evaporation. Perhaps a light breeze strengthened the next day and increased it. Perhaps the pool's shape caused one side to remain shaded a little longer. Whatever the cause, the result is a series of thin pale lines, each one marking a pause in the withdrawal. The basin records not just that water left, but how it left. That is the kind of detail this landscape offers once you slow enough. Not an announcement, a sequence. The sediment here has settled again after the disturbance of flooding. Where the water was calmest, the surface under the thin remaining pools looks almost polished. Where wind crossed more strongly, it appears mottled and softly ribbed. These textures are not ornamental, they affect what happens next. A smoother patch may harden into broad plates. A roughened patch may trap more dust and begin crusting unevenly. Fine relief influences later moisture retention, later cracking, later track preservation. The pan keeps carrying consequences forward. Even when a phase is ending, it is preparing the terms of the next one. Farther across the open floor, heat shimmer returns over the drying flats. Earlier in the day, the shimmer rose over flooded reflection. Now it rises from bare white and pale grey ground. The illusion of water comes back just as the actual water departs. That repetition feels deeply characteristic of Etosha. The basin keeps offering water in different forms. Real water, stored evidence of water, optical echoes of water. A pan like this never fully stops speaking of what made it, even when dry. The flamingos lift in a loose, pale wave from one distant section and settle somewhere farther along the retreating edge. Their movement is unhurried. No alarm in it, just relocation. The place that held the right depth an hour ago is no longer the same place. so the birds redraw their own arrangement across the basin. This is one of the soft escalations of the afternoon. Not more noise, not more crowding, just a subtle thinning of one feeding ground and the opening of another. The pan teaches motion without haste. You come to a broad patch where the new crust has begun to fracture. The cracks are finer than those on older mud, and their edges are bright with fresh mineral growth. Because the surface dried from the top down, tension built as the upper layer shrank over softer material below. Eventually, small fractures formed to release that strain. Later, as more moisture leaves, the plates may curl slightly, separate more fully, or be cemented by additional salts. This is how wide, smooth mud becomes a field of polygons once more. The geometry is practical. Drying creates stress. Stress makes lines. Lines become the framework of the next surface, and within those lines, more salts collect. At one edge of the cracked patch, a trail of tiny bird prints runs straight, then suddenly veers. Perhaps the sediment changed underfoot. Perhaps the bird reached a patch richer in food. Perhaps a narrowing pool drew it off course. The exact reason is less important than the fact that the track responds to conditions. Animals crossing the pan are not moving through blankness. They are reading it continuously. The path itself proves that. A straight line over firm ground, a curve near soft mud, a pause where the prints deepen, a widening stride where the crust sharpens and dries. The surface and its users are always in conversation. Now the larger soundscape begins to simplify again. There are still calls from birds over the shallows, still a faint brushing of breeze. But the fuller acoustics of open water are diminishing. As reflective sheets shrink, they hold less sound. Dry ground takes over. Silence broadens. This is not a return to the exact quiet of dawn. It is a more informed quiet. The basin has passed through presence and is now carrying the trace of it. That trace lies in tracks, in crusts, in faint color bands, in the arrangement of birds and in the new chemistry of the top layer. Dryness after water is never the same as dryness before it. A line of old shore debris appears where the retreating water sorted tiny fragments into a narrow accumulation. There are shell flecks, bits of dry plant matter, maybe a few insect remains, all gathered lightly against a barely raised edge. This kind of strand line is useful evidence. It shows where drifting material was stranded when water dropped below a certain level. It also reveals the direction of slight movement across the flooded surface. Wind can nudge floating fragments. Very weak currents from incoming water can do the same. When their energy fades, the material settles out. Then the line remains after the water has gone. The basin leaves these signatures with remarkable modesty. Nothing exaggerated, just enough to be read. If you kneel by one of the retreating pools, you can see how the water and crust coexist over a span of inches. First there is firm white ground, then a soft pale band where the crust is damp but not submerged, then a gleaming rim, then very shallow water with visible crystals beneath it, then darker mud farther in. This sequence is a cross-section of the whole process in miniature. Dry surface, moist transition, concentrated edge, residual water, soft interior. Any bird feeding here is moving across chemistry as much as across space. Any track impressed here becomes part of the concentration pattern as drying continues. The pan is not only a place where things happen, it is a place where the evidence of happening remains visible side by side. The wider afternoon continues to lower toward evening, and the shadows of low ridges lengthen just enough to make the pan's texture gentler to the eye. The glare eases, colors soften, the whiteness becomes less blinding and more luminous. In that calmer light, the aftermath of water feels broader and more settled. Earlier, the basin still seemed to be actively reorganizing in every direction. Now the changes continue, but they are easier to hold as a whole. The water has withdrawn from many margins. The birds are more thinly spread. The open white is returning as the dominant impression, but it is no longer an unread surface. It has become a page covered in fresh notes. One of the clearest of those notes is repetition. Not monotony, but recurrence. The same hollow that held water before will likely hold it again. The same slightly raised patch will likely dry first again. The same margin may once more grow a pale strand line, or preserve a line of prints, or bloom faintly with microbial color when the next wet phase arrives. This is because the basin's topography, though subtle, is persistent. A flood rewrites the surface, but not from absolute scratch. It works with inherited lows and highs, inherited sediment textures, inherited pathways of inflow. So each season is new, and yet each season remembers. That memory is what gives the pan its feeling of patience. Here, change is real but not hurried. The land does not chase novelty. It repeats useful forms over long stretches of time. A very shallow depression ahead still holds a mirror of sky, though nearly everything around it has dried. The little pool glows more brightly because of the contrast. Around it, the white floor is matte. Inside it, the sky still lives. This last water feels almost ceremonial, not dramatic, just quietly important. Such remnants often persist because the depression is slightly deeper, or the sediment below holds moisture longer, or a thin crust at the edge slows loss by reducing movement. Whatever the reason, the consequence is simple. A little more time, a little longer for birds to visit, a little longer for salts to sort themselves, a little longer before this patch joins the white. And then, eventually, it will. The low sun now reveals tiny ridges around many hoof prints, where sediment was pushed upward when the ground was soft. Those ridges catch crystals especially well. As water lingered in the depressions and along their edges, dissolved minerals precipitated on the disturbed rims. So a print made by passing weight becomes emphasized by later drying. The basin almost outlines pressure after the fact. This gives hoof marks a relief they would not have on ordinary dry soil. They become little sculptural records of timing, made when the mud was soft enough, preserved when the drying was gradual enough, enhanced when mineral concentration reached the right threshold. A track here is geology and behavior meeting for a moment. You move through an area where bird prints outnumber everything else. There must have been a productive feeding band here when the water was only just beginning to retreat. The signs remain in dense but delicate crossing patterns, some overprinted, some fading, some sharply held in newly firming mud. A few tracks begin and end abruptly at the boundary between crust and reflective film, showing where a bird stepped from firm ground into soft shallows, or from shallows onto hardening sediment. It is possible to imagine the movement, but better simply to read it. Here they paced, here they paused, here the beak likely touched down repeatedly, here the ground became too soft to preserve detail. The pan offers enough. It does not require invention. Evening air starts to cool the upper skin of the basin, though warmth still radiates from the ground. That shift can matter to evaporation rates. As temperatures fall, water loss may slow compared with the full force of afternoon. The change is not immediate, but it introduces another rhythm. The retreat of shallows may pause slightly overnight. Crystals may continue forming where concentration is already high. Mud may firm in one place and remain damp in another. Then morning will reveal which changes held. A pan like this is responsive not only to seasons, but to the pulse of a single day. Light, heat, breeze, and cooling all leave their small signatures. This is why watching the basin over hours matters. Without that, the white floor can seem timeless in a vague way. With time spent inside it, the place becomes precisely timed instead. A long reach of the pan ahead has dried enough that the first fine dust skates over its surface in passing gusts. The movement is low and quiet, barely taller than the crust. Dust is returning as a surface actor, not in great clouds, just in thin migrations, collecting against micro-ridges, settling into cracks, softening sharp mineral edges. The sequence continues. Water withdrew, crust formed, cracks opened, wind began to edit. Soon the open white will bear as much evidence of air as it does of the vanished flood. That handover is not an ending, only another phase of the same place. A pale band on the horizon begins to separate from the sky as the sun lowers, and the pan's vastness returns more strongly than it felt at the day's reflective peak. When the water was broad, the basin seemed intimate in a different way, full of nearby details and soft mirrors. Now the openness stretches again. Birds appear smaller, more widely spaced. Tracks become local stories inside a very large field. The emotional scale widens. You are back in the company of distance, but distance has changed character. It is not blank now. It is filled with aftermath. This widening brings the geology back into the foreground. The surface crust beneath you, the compacted clays beneath that, the long history of repeated flooding and evaporation beneath those, all of it feels easier to sense as the temporary water retreats. A few hours of flooding have not hidden the deeper truth of the basin, they have illuminated it. A salt pan exists because water repeatedly arrives and repeatedly leaves under strong evaporation. The day's changes have simply made that truth visible. Every bright plate of reforming crust is a fresh statement of the same process that built Etosha across long spans of time. The ancient lake is not gone in the sense of being irrelevant. Its memory is active whenever water spreads thinly here. A flock of smaller birds lifts from the mud, circles once, and drops onto a newly exposed strip some distance away. Again, the movement is practical. The feeding line shifted. What it sought had become narrower and richer, in the small way that retreating water often becomes richer. A few inches of depth had turned into 1 inch, then less, and that changed who could feed there, and for how long. The exposed strip where the bird settled was darker than the ground around it, which told you that moisture still sat close beneath the surface. That hidden dampness matters in the late stages of drying. Even after the shine is gone, the mud can remain soft enough to release trapped food and cool enough to slow complete hardening. So the birds arrive in that brief interval between open water and finished crust. It is one of the quietest windows in the pan, a place not wet enough to reflect the whole sky, and not dry enough to feel settled. A place in transition, which is where so much of Etosha's life becomes visible. The flock spreads into a loose curve, each bird keeping a little distance from the next. That spacing is not random. When food is scattered thinly through shallow mud, there is little reason to cluster tightly. The birds can afford room. The pan gives them room. And so, even feeding remains graceful here. Stretched out across the white and grey floor, you walk on beside an old, flooded margin that is now only a pale line of mineral dust and darkened sediment. This line is recent enough to still hold meaning. It shows where the water paused before withdrawing again. It also tells you that the retreat was not smooth from every angle. One side of the line is crisp, as if drying advanced quickly there. Another side breaks and blurs, suggesting softer sediment, slower evaporation, or a little wind disturbing the edge. The basin records these differences without effort. A change in air, a difference in texture, a slight variation in depth, each one remains behind as evidence. That is why the returning white feels so articulate. It has the silence of a broad, empty space, but not the blankness of one. By late afternoon, the smell of damp clay is weaker. Mineral sharpness remains, but even that seems thinner now. The air is cooling by degrees. The sun is still high enough to light the flats, yet some of the day's upward pull has eased. This affects the shallow remnants first. A pool that might have shrunk quickly under the full force of noon now changes more slowly. Its edges still whiten. Its center still concentrates, but the pace is softened. Etosha often feels most patient at these edges of the day, when process continues, only with less insistence. A narrow run of prints crosses a newly hardened patch and leads toward the grassier margin. The impressions are small, sharp, and recent. They may belong to a wader leaving the flood after feeding, or moving toward another shallower band. What matters is what the prints reveal about the ground. A few hours earlier, the same patch would have been too wet to hold such clean marks. Now the skin has strengthened enough to preserve them. So the surface is declaring its own change, not by color alone, but by what it can now remember. A stronger crust is a different kind of memory. It keeps edges longer. It holds pressure more clearly. It survives a little more wind before softening into dust. That altered ability changes the appearance of the whole basin as evening approaches. Where the flood was broadest, there are still long silver lanes broken by emergent bars of drying mud. Where the water was thinner, these lanes have already fragmented into isolated shallows, and where the ground was highest by even a fraction, the white has reclaimed the surface almost completely. This is the practical geometry of retreat. Shallow places disappear first. Lower places stay active longer. Minute topography controls the order of vanishing. That order gives the landscape an almost written look. One level after another, one band after another, the water yields itself back to air. The more you watch, the more the pan appears to be made of thresholds, a threshold between visible water and hidden moisture, a threshold between pliable mud and brittle crust, a threshold between fresh inflow and concentrated brine, a threshold between a feeding ground and a place already too dry. Nothing here seems to leap. Everything crosses. That is one reason this landscape can feel so restful, even while it is busy with change. Transitions are slow enough to follow. Near a broad white patch, the crust has begun to flake into tiny plates around the edges of older hoofprints. Those prints are now islands of darker clay. Because they are lower than the surrounding ground, they stayed wet longer. Because they stayed wet longer, they resisted crusting for more time. Now the surrounding area has hardened, and the prints remain as darker, softer pockets inside it. The result is a miniature version of the basin again. Low ground active longer, high ground settling sooner. The same pattern repeats from miles to inches. This repetition is one of the great clarities of Etosha. The pan behaves consistently across scale. A large depression gathers floodwater. A footprint gathers the last dampness. A broad margin becomes a feeding belt. A tiny crack becomes a line where salt can collect. The logic does not change, only the size. Farther toward the center, where the flats open wide again, the birds are fewer now. The basin seems to exhale them. Not completely, only enough that space becomes dominant once more. As water contracts, the places worth lingering in become fewer, and so the life that was briefly spread across a broad reflective surface gathers into selected strips and hollows. That gathering can look like emptiness returning, but it is really selection. The pan is sorting activity into the places where conditions still permit it. The rest settles back toward stillness. You notice one low pool that has become ringed by several shades at once. There is a bright white outer rim. Inside that, a pale beige band where wet crust has not fully dried. Then a darker brown strip of exposed mud. Then the remaining water, faintly pink under the lowering light. Each ring marks a stage in withdrawal. Each stage comes from the same sequence. The shallowest water evaporated first and left a clean mineral edge. The next band remained damp longer. The next held open mud after the crust softened. The center kept enough depth to remain reflective. So one pool contains a full account of how the day has passed, a quiet history in circles. That little ringed basin also shows why the pan can never be understood only from far away. Distance gives scale. Nearness gives process. From afar, Etosha is a white immensity. Up close, it is a system of pauses and consequences. And when those two views combine, the place becomes much more than scenery. It becomes readable time. The late sun now lowers enough to pull warmth from the colors. The whites turn gentler. The gray clays look cooler. The pinks in the water become more subdued, almost breathed away. At the same time, relief shows more plainly. Slight rises cast faint shadows. Drying polygons emerge with a clarity hidden earlier in glare. This makes the basin feel more textured without making it busier. Evening often grants detail by softening brightness. Where the ground begins to rise toward the outer plain, Sparse grasses catch the light and become a low golden fringe beyond the pan. That edge has been present all day, but now it regains importance. As the center quiets, the margins begin to hold the remaining movement. Birds drift there. Insects remain where dampness lasts in the soil. Larger animals may cross after the heat eases, leaving fresh tracks on the cooling mud. The pan's center tends toward austere openness as evening advances. Its edge retains a little more conversation, but even there, nothing feels hurried. One of the most gentle changes now is sound. The broad, soft hiss that accompanied larger water surfaces has nearly gone. In its place comes the faint, dry whisper of wind passing over crust, and the occasional call from birds farther off. The pan is simplifying itself acoustically. This is not silence in a perfect sense. It is distilled sound. The noises most dependent on open water are fading. The ones tied to distance and dry ground remain. That change deepens the sense of return. Not return to the opening exactly, but return informed by what the day has shown. The basin that seemed blank at dawn now bears a visible aftermath. A line of darker sediment leads away from one shallow depression in a delicate fan. It must have formed when water overflowed the depression briefly as a gust pushed the surface, or when the pool connected to a neighboring hollow and then separated again. The fan is faint but clear enough to show that even the final stages of retreat can still involve movement. Not large movement, just enough to sort a little clay and leave a pathway. This matters because it reminds you that drying is not merely subtraction. Water does not only vanish. Before vanishing, it often redistributes. It shifts from one place into another, it leaves one low point and lingers in the next. It recedes, but not always straight backward. So the last hours of a flooded pan are full of tiny reroutings. Those reroutings are written in fans, seams, and residue lines. Near one such fan, the sediment is strewn with minuscule crystal clusters, each one catching the lowered light with a soft brightness. Earlier they would have been lost in the glare. Now they become visible because evening is kinder to small things. These crystals tell you that concentration has become strong enough in the thinnest films for minerals to gather quickly. They also tell you that the surface has remained quiet enough for such delicate structures to survive. A stronger wind might have disturbed them. A fresh sheet of inflow would have dissolved them. Instead, they have had time to appear. The pan rewards stillness by becoming more legible. A solitary flamingo remains in a remnant strip of water farther out. Its body is pale enough that it nearly merges with the basin around it. Only its movement gives it away. It lowers its head, pauses, lifts it again. This single bird says something larger than itself. There is still enough depth there, still enough chemistry there, still enough small life there. Not much, perhaps, but enough. And because the pan is so wide, enough can persist in one narrow strip long after the surrounding flats have resumed their dry calm. This is one of Etosha's quiet strengths. It can hold many phases at once. Open water in one place, fresh crust in another, soft mud at a margin, dust beginning to move across a fully dried reach. The day's changes do not proceed as one advancing front. They spread in patches. That patchiness is the key to the pan's ecology. It creates variety without clutter. It creates choice without crowding. You move over a stretch where the crust has set into broad pale plates, divided by darker seams. In the seams, salts have begun to concentrate again. This is because cracks can guide the last rising moisture toward the surface. Fine spaces in the drying sediment pull water upward. As it reaches air, it evaporates, and dissolved minerals remain along those narrow routes, so the cracks become more than signs of shrinkage. A plate of drying mud is never only a shape. It is also a map of where water last moved. The same is true of the broader basin. Its old channels, slight hollows, shore traces, and low aprons are all maps of movement slowed almost to stillness. Even a landscape this calm is made by roots. Rain falls somewhere beyond the horizon. Runoff follows shallow lines. Water enters the pan, it spreads according to relief. Then, after spreading, it retreats according to relief again. Those routes are not dramatic, yet they are the entire story. Without them, there would be no white basin, no flooded mirror, no returning crust. Only a different plane. Etosha exists because water arrives imperfectly and leaves reliably. A faint blue begins to gather in the shadows of the farther flats, not in the sky yet, but on the ground itself where the light has weakened. The white of the pan takes on that coolness quickly. Salt and pale clay are very responsive to the hour. At noon they glare. By evening they glow, then cool. The result is that the basin becomes less radiant and more spacious. Its brightness stops pressing upward. It begins to settle. That settling changes how you feel in it. The same open floor that looked almost liquid at midday now feels ancient again. Dryness has a way of restoring age to the scene. Temporary water brings immediacy. Its retreat restores the longer view. With more of the pan exposed, the geology underneath the day's events becomes easier to hold in mind. This floor has endured countless similar cycles, not identical ones, some years wetter, some drier, some inflows more generous, some almost absent, but always the same underlying balance: brief water against persistent evaporation. That balance, repeated over very long spans, is what assembled this basin grain by grain. Clay settled from still water, minerals remained when water departed. Wind shifted fine surface material across long dry intervals. New floods reworked old crusts. The pan did not appear once, it accumulated. A place like this teaches patience because it is made from patience. That realization becomes especially strong when you stop moving. If you stand still and look out across the broad returning white, the present season seems only a thin layer over deep time. The fresh bird prints are recent. The new crystals are recent. The receding pools are recent. But the conditions that allow such things, the shape of the basin, the chemistry of repeated evaporation, the inherited texture of sediment, are far older than any one day. The pan is temporary at the surface and ancient underneath. That dual feeling is part of its calm. It changes constantly, yet never in a hurried way. A cooling breeze moves from the darker grassland edge onto the flats. Now it is dry enough to carry a little powder from the brightest patches. The powder travels low, then settles into seams and hollows. Once again, the air begins to edit what the water left behind. The handover continues. A day that belonged first to crust, then to flood, then to chemistry, now leans more fully toward evening dryness. Still, some dampness remains in selected pockets, and so the story is not one line but several running together. That layered overlap is what keeps the pan from feeling simple. It is broad, yes. Open, yes. But never singular. At the edge of a shallow depression, a fine line of insect tracks scribbles across wet mineral mud. These are very small, almost absurdly delicate, beside the wider hoof prints and bird marks nearby. Yet they belong just as fully to the basin's record. Because the mud remained moist a little longer here, tiny lives could cross it. Because it remained exposed rather than flooded, the tracks could hold. A different timing would have erased them. So even these minute signs depend on sequence. The pan is full of such timing. Who arrived while it was soft? Who fed while it was shallow? Who crossed after it hardened? Who left no sign because conditions did not allow one? Every mark is permission granted by the surface. The sky is now broad and clear in a quieter way than it was at midday. Its color deepens. Its reflections in the remaining pools become more precious because they are fewer. Where broadsheets once held whole cloud forms, now narrow remnants hold only strips of brightness. That reduction can make the last water feel more luminous rather than less. Concentrated things often do. A little silver lane in a field of matte white can command more attention than an entire flooded expanse. The basin knows how to become spare. As it does, the birds thin further. A few still pace the residual edges. Most have moved toward more favorable shallows or toward the outer wetlands where other opportunities remain. Their departure is gentle. No dramatic lifting of the whole landscape, only a gradual easing away of scattered life. This thinning of movement allows another aspect of the pan to emerge, the immense patience of ground itself. Once the shallows withdraw and feeding lines shift, what remains is sediment, salt, air, and time, the essentials. A broad field of pale earth carrying the traces of a brief season of water. You walk over ground that was under a thin reflective sheet not long ago, and now the crust responds with a faint brittle sound. This small sound is important. It tells you the drying has advanced from surface appearance into structure. The top skin has become rigid enough to crack under light pressure. Soon it may become powder at the edges. Later, it may be broken by wind, or softened by dew, or reworked by another pulse of water. For now, it is simply new crust, freshly returned white, a skin laid over memory. It is tempting in a place like this to think of dryness as absence, but that would miss what the basin is doing. Dryness here is an active state. Salt is still moving in the top layers, mud is still shrinking and opening into polygons, wind is beginning to sort fine particles, tracks are being preserved, blurred or outlined depending on where moisture remains. Even cooling temperatures are altering the pace of evaporation from the last pools. The quiet is full of work. That truth extends beyond this one day. Over decades, shifts in rainfall, in the paths of runoff, and the persistence of seasonal shallows all leave their signatures in the basin. Over centuries and longer, sediment accumulates, minerals redistribute, and the surface itself changes by small increments. The pan is never finished. It only appears settled between revisions. That is perhaps the deepest calm a landscape can offer. Not finality, but ongoingness without strain. Ahead, the flats broaden into a pale openness that seems almost to absorb the lowering light. The remaining pools are farther apart now. The cracks are more continuous. Strand lines, feathers, shells, and tracks are more obvious because there is less water to distract the eye. Aftermath becomes the dominant texture. The basin is teaching once more that emptiness is often only a first impression. Stay long enough, and emptiness resolves into evidence. The farther you look, the more this ancient floor feels like a memory system. Not a memory in the human sense, but in the physical sense. A basin that keeps traces. A surface that records where water stood, where life gathered, where the wind began again. An archive made of mud, crust, and light. And as the hour lowers further, that archive begins to cool under the first approach of evening. The pale ground releases the heat it gathered all day. The air just above it softens. What remains wet cools differently from what is already dried, and these slight thermal contrasts can matter through the night. A damp depression may stay softer by morning, a crusted plate may tighten and become more brittle, a residual pool may hold a little longer than expected if the night is calm. Then dawn will read those overnight decisions. But for now, you are still inside the last light of afternoon, where the pan is neither bright with flood nor fully given to night. It is in that balanced hour when the day's processes remain visible all at once. A long white reach ahead has almost no marks at all, and because of that it feels especially deep in time. Not because nothing happened there, but because what happened has already been smoothed. Perhaps the flood was thinner there. Perhaps the wind has had more reach across it. Perhaps the crust reformed evenly. Whatever the reason, the near blankness becomes meaningful after all you have seen. It is not ignorance, it is a different result. One part of the basin preserves many signs, another returns quickly to spare simplicity. Both belong. This balance between readable detail and open quiet is part of why Etosha never feels overwhelming. There is always space between the signs, always room for the eye to rest. And so you keep moving across the ancient floor as the white regains itself.